My name is Cemre Şönökü. I'm a second year student in Industrial Engineering Department of Bilkent University. I will be presenting my Physics 102 lab experiment which examines the relationship between the number of turns of the coil and the electromotive force obtained by the magnetic flux change by using Faraday's law. The aim of this experiment is to demonstrate the proportional relationship between the number of turns coil, which represented by N in the formula, and electromotive force by using Faraday's law, and to observe the electromotive force only appears when the electric flux of the system changes. In this experiment, magnetic flux will be changed by moving magnets closer to the coil. In essence, Faraday's first law illustrates how electricity and magnetism are related. An electric current is obtained by an electromotive force created when the magnetic field surrounding a conductor changes. Faraday's second law of induction asserts that the rate of change of magnetic flux, which in this experiment is originating from changing the distance between the magnet and the coil, is directly proportional to the electromotive force, and the unit of EMF is volt. When a magnet moves closer to the coil, the magnetic flux in the circuit increases. Magnetic flux can be formalized as magnetic field times the area of coil, which is perpendicular to magnetic field. As magnetic flux changes, the coil induces an EMF. Therefore, electrical current will appear in the coil. The current of the coil creates an electric field which opposes the magnetic field. This situation can be explained by Lenz's law. According to this law, the induced current resists the change in magnetic field which is originated from EMF. Therefore, if we cannot connect a galvanometer or multimeter to the coil, then we can detect deflection by the magnet. By the Faraday's law, EMF depends on the magnetic flux change in time and the amount of coil turns. Therefore, the formula of EMF is minus n times magnetic flux change in time. Equipments that I had used in this experiment: a multimeter to find EMF value, a ruler to fix the coil, magnet to create magnetic field, coils with different numbers of turns as an independent variable. Procedure of this experiment: first, obtain 5 coils with same areas but different numbers of turns. Therefore, the magnetic flux will remain same. In this experiment, the n values are 5, 10, 15, 20, 25. Use a handle. In this experiment, it is a ruler to fix the coil at some height parallel to the ground. And third one is connect parallel the multimeter with coil to observe the deflection. PS, sandpaper the end of the coils to make them conductive. The third one, the experiment aim is to observe the relationship between N and EMF. Therefore, with the help of the ruler, the magnets must be left from the same height in each try. The velocity be equal for every experiment. Since the conservation of energy, the potential energy at the first will turn into kinetic energy. Since the mass of magnets won't change and magnet will be released in the same height, in this experiment it is 30 centimeter, the velocities will be the same. And without giving an extra force, release the magnet from the predetermined height into the coil. Observe the deflection into the multimeter, which gives the EMF induced in the coil. Repeat this experiment with the other coils with different numbers of turns. Write the data collected from the experiment to the table 1 and draw a graph of EMF and N. Then calculate the error percentage. The data shows clear positive linear relationship between the number of coil turns and average EMF, supporting Faraday's law of electromagnetic induction. Optimal line matches the data points closely, indicating constancy in measurements. I calculated error percentages by comparing EMF proportion between coils and the ratio of the number of coil turns. The data points are relatively close to the optimal line, confirming a strong correlation. However, minor deviations from the line could be attributed to measurement error. This error might originated from inconsistencies in release height of the magnet. In each try, I try to release the magnets at 30 centimeter. However, I do not use any automatic mechanism to adjust the same height conditions. Therefore, some errors arise and inaccuracies in multimeter results. Since EMF value is only observable in a instant time, multimeter might not a precise measuring equipment.